Today's lesson is on completing the square. Basically, what it means to complete the square of a quadratic equation is to take that equation and transform it into a perfect square trinomial. This is now the fourth way that we've learned how to solve a quadratic equation. Before we can actually apply it to quadratic equations, let's remind ourselves what it means to be a perfect square trinomial. In last chapter, this is when we would factor a trinomial, and its factored form was a squared binomial, such as x squared plus 6x plus 9. That is a perfect square trinomial. We had the little criteria in order to figure out if it was a perfect square trinomial. Either you can go through that if you remember it. You had to have the square root of the third term had to be, the first and the third term had to be both perfect squares, which x squared is perfect square and so is 9. And then when you multiply those two together and take the square root, doubled gives you the middle term. Again, if that is hard for you to remember, then you're going to have to go through either the drop-down method or just regular factoring in order to put it in its factored form. At that point, you will see that it's the same exact binomial. Maybe when you factor it using one of the other methods rather than doing it in your head, you get something like x plus 3 times x plus 3. It would be your job to realize that that's the same exact binomial, and it would be written as x plus 3 squared. At that point, you'd realize that that is a perfect square trinomial if you couldn't check it from the beginning. Let's practice a few where we're just simply we're going to complete the square. We're going to find a number that makes the trinomial a perfect square. So there's a method to this, and when you get good at it, then you can just do it totally in your head. So what you're going to do to be able to fill in the missing term, the third term, to make it a complete perfect square, you are going to take your middle term, divide that by 2, and square it. 10 divided by 2 is 5. 5 squared is 25. So to complete the square of this first example, I would complete it with the number 25. All right. The negative sign in this one doesn't really matter because when you go to divide it by 2 and square it, you end up getting a positive number because the negative gets squared. So in this problem, this would give me positive 81 over 4. Now, we can leave it as 81 over 4. That's what we're actually going to want to do. We don't want to make decimals when we're completing the square. So keep it as a fraction. If it could be reduced, then of course you're going to reduce it. But in this case, 81 over 4 does not reduce. Okay, in number 3, again, middle term, it's always going to be that you divide it by 2 and you square it. And again, you'll get good at this where you can just simply do it in your head. So number 3, we're going to complete the square with 36. Again, with the negative, when I divide and square it, the negative sign will go away. Again, I don't want to make this like negative 2.5. I don't want to do that in this section. I want to keep it as a fraction. There will be a reason for that down the road, so do not make this a decimal whatsoever. And also mixed numbers, we don't do that either. So in this case, this would give me 25/4. The third term is always going to be positive. It has to be in order to be a perfect square trinomial. Okay. I think we just did negative 9 over 2, did we not? We did. The book used 2 examples, so let's forget that one. Or just for fun, go ahead and do it again. Okay, here we have negative 6 divided by 2 squared. This will give me negative 3 squared if you want to see one that's actually negative that's not a fraction, and that would give me positive 9. All right, we're now going to actually apply it to a quadratic equation. Okay, when we have this, you actually want to keep the 15 in this particular problem on the right-hand side. I just want to open this up to leave a little hole for me to complete the square right here. This is what I want to do. It's going to be a positive. Now, I'm going to go through the process that we were just doing to complete the square. 14 divided by 2 squared, that gives me 7 squared, which gives me 49. So I'm going to complete the square with the number 49. Now the catch is you do have to add it to both sides of the equation. Now I'll do the step off, we'll skip a step over here, or skip that area where I worked, and I'm just going to rewrite it now that on the left hand side I have completed the square. I will simplify this over to the right, which is 64. Your next step, and the whole goal behind completing the square, is to put this equation in factored form, and it's x plus 7. Once we have this, we are now able to use square roots in order to solve the problem. So it's actually a 2-for-1 here. Not only are you completing the square, but it leads you to be able to use square roots. So when I take the square root on the left, the square root of x plus 7 squared is simply x plus 7. The square root of 64 is plus or minus 8. Now you'll split this up. Again, if you can do this in your head, that's fine. Of course, when it comes to quiz time later on in the week, you will have to show me every single one of these steps. Because of the nature of this type of online quiz, you are going to have to show me all of your steps, including those ones that normally we could do in our head. So the answer is 1 and negative 15. You can check your answer by plugging it back into the original equation and to see if it works. You can also test it out in your calculator by going and typing in the equation into y equals. However, in this circumstance, if you're going to do that, going back up to the original, you would have to subtract 15 on both sides so that it equals 0 before you type it into your calculator. And then you can check using the table to see if those are your two answers. To be honest, the easier way to check this would be to take the 1 and negative 15 and just plug it back into this original equation. Make sure you get that it checks out and that you have, if you get the 15 on the other side, if it equals 0, if you leave it the way that it is, that you end up having, it all works out on both sides of the equal sign. Okay, let's try another one. In this one, notice it equals 0. I don't want it to equal 0. I want to open up the space in order to be able to complete the square. So what I'm going to do is I'm going to add that 2 over to the other side. So again, this is going to open up a space right here that I am going to add the same number to both sides. So now I have to figure out what I'm going to add to both sides. And again, you take the middle term, divide by 2, and you square it. That's going to give me negative 1 squared, which gives me 1. So that means I'm going to add 1 on both sides of the equal sign. Now I have x squared minus 2x plus 1 equals 3. Now I want factored form because that was my goal. This one is going to be x minus 1 squared equals 3. Now I got to the point where I can use square roots, so I'm going to take the square root. On the left, I get x minus 1. On the right, unfortunately, this one isn't as pretty as the other one. This one is the square root of 3. So what I'm going to leave it as is the square root of 3, plus or minus the square root of 3. Now I have to change this. If you want to write it out into the two steps, I've got positive square root of 3, and I have negative square root of 3. Again, the negative sign is not underneath the square root sign, so it's okay. You're allowed to be able to do that. So you're going to add 1, so I have the square root of 3 plus 1, and I have negative square root of 3 plus 1. You can write your answer like this, or you can use the plus or minus sign, which would simply be 1 plus or minus the square root of 3. Either way is acceptable. This, with the plus or minus sign, is the more popular way to write the answer. But again, it's up to you which way that you want to write it. If you want to write each one separately, you can also write either one of these if you want to flip it around so it's like that. You can do that as well. All right. For our next problem, again, this one, I'm going to just widen it a little bit so that I have room to complete the square. Okay, don't worry about the fact that this is negative yet. Just go ahead and complete the square. 10 divided by 2 squared is going to give me 25. So I'm going to add 25 onto both sides. X squared plus 10x plus 25 equals negative 9 plus 25 is 16. Now I'm going to write this in factored form. X plus 5 squared. My next step is going to be to take the square root. This gives me x plus 5 equals plus or minus 4. This one was a pretty one because 16 was a perfect square. Again, I'll separate the two into two easy algebra equations, one equaling positive 4 and one equaling negative 4. And you get your answer of negative 1 and negative 9. All right, so this one doesn't have x in it, but we're going to go through the same process. The directions are always just going to, right now, you're going to be forced to use completing the square. You're not going to have that option to pick one of the other ways. The directions here are going to be completing the square, and you will have to show how you did completing the square. So again, I'm going to open up the space so that I can complete the square. All right. Now I have to figure out what is going to go here and here, what is going to be added to both sides. So again, I take that middle term of negative 8, I divide it by 2, and I square it. This is going to be 16. So I have a squared minus 8a plus 16 equals 21. The left is always going to be factored. If it can't be factored, you did something wrong. You did not add the correct number on both sides to complete the square. So this is x minus 4 squared, and then I've got 21. You can already see 21 is not a perfect square, so when I go to do square roots, this one isn't going to be as pretty as the other ones. This is going to be plus or minus the square root of 21. Again, if you want to keep it like this, I would add 4 on both sides, so my answer becomes 4 plus or minus the square root of 21. Again, this is the more popular way. If you want to separate it into two, you have x minus 4 equals positive square root of 21. You'd add 4. And then you would have x minus 4 equals negative square root of 21. So you can write it separate if you'd like. So either way is acceptable. Again, this is the more popular way to be able to write your answer.